Um, Hello everyone. In this video, I'm going to do a demonstration on my course project. This course is EEL6525, and my name is Chenyun Xu. This course is taught by Dr. Wu, and my topic is face recognition by using FaceNet. And the first part is introduction. What is FaceNet? Um, there are many ways to distinguish two kind of faces. And in this part, you can see that the FaceNet just map the image to a Euclidean space with distance. You can see that in the right, there are 6 pictures on the right part, and you can see that our 2 pictures between our 2 pictures there is a distance and such as 1.04, 0.78, 0.99. And if we want to distinguish whether those 2 pictures belong to the same person, we can set a threshold such as 1.1. And according to this property, to the distance property, and we can see that 1.04 is smaller than 1.1, and these 2 pictures belongs to the same identity. 1.22 larger than 1.1. These 2 pictures belongs to the different identity, and we can after we map them from map the distance, we can use CNN to train the distance and embedding itself. And this part told is a method how to implement the algorithm. And we introduced a new concept called triplet loss. What is triplet? Triplet is kind of 3 elements, and the anchor represents the original image, which means that the image that um, you choose as a base. The negative means that the image that represent the different identity to the original image. The positive means that the image that represent the same identity as the original image. Uh, as we see in the above part, we need to set the distance between. We need to train the data and make the distance between anchor and positive is smaller than the anchor and the negative, so we can distinguish positive and negative. It need a training process, and which we just send this kind of part to the deep neural network. This is a formula. This is a formula to represent the figure that we shows above. And in this part, XIA means the anchor, XIP means the positive, XIN means the negative. The distance between the anchor and the positive plus alpha represent the distance of the margin. It will the left part will less than the right part. We need to set this formula to every image in our database. Every image in our database must satisfy this formulation, and um, we just do some transformation to this formula, and we sum all the images together. We can get a triplet loss, and we need to minimize the triplet loss so we can get our result efficiently. If we minimize it, we can say that it satisfies all the all the triplet will satisfy the all, all the triplet will satisfy the above formula. So our goal is to minimize to find our goal is to find all the triplets in our database and do the computation. But find all the triplets in our database is impossible because it will cost a lot of time to do computation, and so we need to do triplet selection. We need to select some proper triplets. And first of all, we need to select hardest per image in the same person as XIP, which means that we find the positive image has the largest distance, which is furthest away in the database, and selected the hardest negative image, which means that we need to select the image with different identity, the distance of the image with different identity to be smallest in our database, which means that they are closest in our database. Um, if we satisfy those two conditions, any other triplet will not violate the formula that we shows above. It's this formula. And but to find the hardest and positive and negative is not easy in the whole database. So we implement a mini batch. We just need to find the hardest negative and positive in mini batch. It's a part of database. It will reduce the computational complexity obviously. This part, this slide shows that the difference, the performance of different kind of deep neural network. Deep neural network is this part, is this architecture. We can see that the NN2 has the best performance, but it has the highest flops. The flops is the computational rate. There is a trade-off between validation rate and flops. If we want to deploy our algorithm in the mobile devices, we can use NNS2. NS2 is 70%. It's about 70% validation rate, which is acceptable, but it's only about. But it has smaller. It has very small flops, so it can be deployed in our mobile devices. And to do our environment, we use the LFW. It's a labeled face in the wild data set to evaluate our algorithm. The LFW is established by the University of Massachusetts College, and it consists of 13,000 different face image and 5,000 different identities, and the size of the data set is satisfied our demand. After we get the face data, we need to do alignment. The alignment means that we extract the main feature from the picture. For example, in this part, we extract the main feature from the left image to the right image, and to deal with the right image, we can get performance. We can get better performance in the end. We use MTN CNN alignment algorithm to realize the face alignment. And I will show you demo about the project. First of all, the LFW means that the dataset download from the LFW database, and you can see that the picture is not aligned. So and after alignment, after we run the alignment algorithm, we can get the pictures realigned that which is extract the main feature from the original images. And this picture can help us to get better performance in the end. And because to run this algorithm, validation algorithm will cost a lot of time, so I run it in advance. I run the validate on lfw.py. This lfw, the align file is that the picture after alignment is that the image after alignment, and the models and the model file is that the training model. I've trained this model in advance, so I can use it in this part. And the validate on FW part is here. It can help us calculate the validation rate and error rate. It shows here. We can see that the accuracy is about 99%, and the validation rate is about 97%. The error rate is very low, and the area on the error rate is very low. So it means that the FaceNet algorithm can recognize the face successfully, and the output data is shown here. The first line, the line LB Patchlow 1 4 means that the picture one and the picture 4 are recognized successfully to be LB Patchlow code. This means so if a line just have only one name, it means that they are recognized successfully. But let's in this part. In a line, it shows two names. It means that the algorithm recognize these two person to be the image of these two person to be the same people, which means that it's wrong. And the validate.py algorithm, the 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 function of that algorithm is that to calculate the validation rate and the error rate based on the dataset. This slide shows the result, and we can conclude that the FaceNet face recognition algorithm is very successful. That's all for the demonstration. Thank you for your watching. Thank you so much.